Okay, so a car was valued at $32,000 in the year 1994. The value depreciated to 14,000 by the year 2002. That's like 8 years later, right? What was the annual rate of change between 1994 and 2002? So, how fast was it basically going down? Well, this we're assuming, we're assuming exponential decay. The car is depreciating by the same amount every year. So we're going to use, from the notes right here, if a function grows or decays by the same percentage each period, that's what the car is doing, right? It's going down in value by the same percentage. This is called exponential growth or decay, and the function is this, where p is the amount at the start, r is the decimal version of the rate of growth, positive, or decay, negative. So let's do that. So on part A, down here, part A, down here. All right, so what does it say? The annual rate of change. So, okay, so we know the formula. It is going to be f of x equals, from the notes, p, and then this is 1 plus r to the t. Again, I'm getting that formula right here. F of x is p, 1 plus r to the t. Okay, so the car was valued at 32,000. So that's our p, because it's, as it says right here, p is the amount at the start. Okay, and then 1 plus r, we don't know, well, that's what we're trying to find is the rate, right? What is r? And what we're being told is by the year 2002, it was down to 14,000. So that means the function had dropped to 14,000, the function value, right? P is the original. This is the original. Here, let me, yeah, right here. That's the original, the dollars originally. This is the dollars now, right? It dropped by the year, the dollars in the year 2002. You see what we're saying there? So f of x, the 14,000, that's the dollars in the year 2002. The same as worth 14,000 in the year 2002. This is the original. And the t, how much time? What is time? From 1994 to 2002, that's 8 years. So that goes right there. That's the time. The time is 8 years. So after 8 years, the value dropped from 32,000 originally down to 14,000 in 2002. Okay, so I need to solve that equation. Let me write that now. Solve for r. So how do I solve that equation for r? That's not easy. Definitely not easy to get r alone in that equation. Put in the wall of separation here. So, okay, so first thing we're going to need to do is divide by 32,000. Trying to get r alone, right? Bonk, bonk. We got that, and we get 1 plus r to the 8. I'm going to take the other side, and I'm getting 0.4375. Good so far? I just divided by 32,000 on both sides. Get rid of that. 14,000 divided by 32,000 is 0.4375. So we're getting closer. We're trying to solve for r. Bring it down here a little bit further. Keep the wall of separation going strong. Okay, so I'm trying to solve for r. Got to get r alone. R is saying, I want to be alone. I want to be alone. Get rid of that. Get rid of this other stuff. Get rid of this 8 power. Get rid of this 1. Get rid of these parentheses. I want to be alone. All right. So how do I get rid of that 8 power?
Square root to the 8.
Yeah, you can 8th root it or 1/8 power. Either way, it's the same thing. I think this time I'll show the other way, the 1/8 power. But it's good either way. It's the same thing. Either 8th, or y'all say, or 8th root. Both sides. It's the same thing. A 1/8 power is an 8th root. There are two ways of saying the same thing. Yeah. And then these guys cancel. And you get 1 plus r. And this one, I'm just going to leave it for now, 0.4375 to the 1/8 power. That gets rid of the 8 power, right? A 1/8 power is the opposite of an 8 power. Or you could also do an 8th root, same thing. Now you want to get r alone, so last step, subtract 1. Just subtract 1 from both sides. Boom, boom, that's gone. R indeed is alone. So what is it? 0.4375 to the 1/8 power minus 1. Hit the buttons on your calculator. Do you know how to do that? Let me write that out for you. I'm glad to help as well. 0.4375 to the power. For most cases, be up arrow or x to the y or x to the blank. And then you're going to have to go parentheses 1 divided by 8, then minus 1, and hit equals. You've got to do that power in parentheses. Why? Because that way, if you didn't put parentheses, if all you did, if you just left these off and left these off, it would only raise it to the first power. It wouldn't know the 8 is part of the power deal. It would just think, oh, you just want me to take 0.4375 to the first power and then divide the whole thing by 8. It doesn't know. No. The 8 is up there in the power with the 1. Well, how you tell your calculator that is parentheses. Parentheses are grouping symbols. They group the 1 and the 8 together, telling the calculator the whole thing is the power, 1/8 power. The 1/8 power minus 1. I'm getting the answer. R equals negative 0.098175. It's negative because it's a decay, right? R is going down in value. So that's our, and they wanted 4 decimal places. So how do I round that to 4 decimal places? Let's do it. 1, 2, 3, 4 right here. And that 7 says to round that up. So the R will be negative 0.0982. So there it is, rounded to 4 decimal places. And that's part A. And then part B says, what is the correct answer written in percentage form? So here's the answer to part A. And then part B is a piece of cake. They just want the percentage version. So the percentage version, how do you change from a decimal to a percentage? You know, you move it 2 places, don't you? It'll be negative 9.82%. That percentage on the end here is kind of like a magnet, and the decimal is like a piece of metal. It pulls it. Was over here, it goes 1, 2. It pulls it towards it 2 places. That's why there's 2 zeros in the percentage symbol. It reminds us to move the decimal 2 places. So there's the decimal version. There's the percentage version with the decimal moved 2 places to the right. Still negative. And then part C says, assume that the car continues to drop by the same percentage. What will the value be in the year 2007? Okay, so in the year 2007, so now that we have our R, let's see if we can, and it says round to the nearest $50. That's interesting. Just round to the nearest $50. Okay. And what year was that? 2007. 2007. Okay. Let's do that. Value in the year 2007. Well, what was the formula? It was f of x equals, let's go back up here. Right here. P, or 32,000, 1 plus r to the 8. So it was 32,000, 1 plus r, well, to the t power. 32,000 was the starting amount. Starting in the year, I think it was 1994, wasn't it? Yeah. And then now they're asking us in part C to go all the way to the year 2007. So in 2007 minus 1994, that's 13 years. So this is 13 years later. So I'm going to plug in 13 for T, and then the R is this number right here. Put that in. So we're going to get, oops. One plus R, what's R? Negative 0.0982 to the power of 13. Does that make sense? That will be the function value, which is the value of the car in the year 2007, because that's 13 years later. So on your calculator, then type this in and use the parentheses. So I would type it in just like it looks with the parentheses and the power button. To the 13th power, I'm getting 8348.01. So the car is worth 8,000. It shrunk down. It's going down, down, down. It started at 32,000 in value. Remember, it went down. They said it went down to 14,000 by the year 2002. Well, now it's down to 8,340. But they want me to round it, don't they? Round to the nearest $50. They said, what would that be rounded to the nearest 50? 8,350 bucks. Right? It's closer to 8,350 than it is to 8,300. Right? 8,350 is just above it, and 8,300, the next 50 down, is below it further. So it's closest to 8,350. So rounded to the nearest 50, we're saying, hey, that car's worth about 8,350, or will be in the year 2007, about 8,350 using that formula. And so there we go.